recording. Yeah, I know I was mostly just shoveling snow. That was how my snow day went. That's how it works when you own property, particularly when you have a corner lot and a very large driveway. But you know, there are compensations to living on a corner lot. They're also statistically more likely to be broken into. So we were talking about JavaScript. If everybody could please load up their favorite code editor, that would be fan-flippin-tastic. So I'm recording this. I guess in the end there will be two versions of this particular class. The version that I did yesterday, because I kind of sneakily converted it to a live stream class, you know? I know technically you're not supposed to do that, but essentially I can't have that section be 2 weeks behind. I would have had to have scheduled a makeup class at some point, and like at any other time, all the people in the class are going to have conflicts, right? So to me, it seemed most logical to just kind of keep the class where it was temporarily, move it online, and it's recorded for the benefit of anybody who wants to watch it later. You could even go back, compare this one, compare that one, see if I did the same lesson twice, you know. That's probably a waste of your time, but you know, people waste their time in all kinds of interesting ways. So, if my memory serves, we should be round about here, functions in JavaScript. So, did we, do you remember if we did, do you guys remember where we left off? Anybody?
We had the function adding 3 different things, and then we were seeing how it was doing. It's able to do the unexpected behavior because of how JavaScript can like add
the undefined literal.
Yeah.
Yeah. Okay. So, all right. We have a few more things to talk about with respect to the manner in which JavaScript deals with its functions. So, this business where if you write a definition for a function and then you undersupply that definition with arguments, you don't give it enough parameters, it inserts undefined. This is JavaScript's attempt at producing polymorphism. This is what it does instead of overloading. Now, I believe in Java you folks will have seen overloaded constructors. It may not surprise you to learn that in Java you can do that with any function or any method, not just constructors, right? That's how Java handles polymorphism in this way, is by you define it once for every way you expect it to be able to be called. This is a very Java way of going about it because it's very verbose, right? In JavaScript, way that it chooses to handle this is to have one function definition, right? But all of the, all of the different possible ways it can be called occur between dynamic typing and being able to undersupply with arguments. Did we do default values? Does anybody remember?
Is that where inside the argument you can just set like the variable to a specific value?
Yeah,
And then
I think I know where I'm going to start doing code examples, and it's about here. So, yeah. So let's make ourselves a nice, tasty little HTML file. Today is St. Valentine's Day. Index.html, there we go. Let's make a new one. Call it myscript.javascript. There we go. And of course, we will need to import that. Script source is equal to myscript.js. And script. There we go. So, let's create a new function definition. Let's even return to our good old add3 example. Function add3 x, y, z. Return x plus y plus z. There we go. Let's open her up. Add 3, 1, 2, 3. As you can see, if I undersupply with arguments, I get not a number because the thing that used to be a 3 is now the undefined literal. The undefined literal, when you add it to something, results in not a number, another literal, being carried through the calculation. So far, so good? So, the question then becomes, how do we choose to handle this complexity? Well, there are a couple of ways of doing it. The sort of bad way of doing it would be to write if statements checking to see if x, y, or z are undefined. I won't do the full version, I'll just check for z.
Excuse me, sir.
Oh, yeah, sorry.
Could you zoom in?
Oh, yeah, certainly, sorry. Is that better?
Yeah, thank you.
You're welcome. Sorry about that. In the interests of time, I won't do the full thing out, checking for both x, y, and a z being undefined, although if you wanted to use this approach, that's what you would have to do. Here, I'm checking to see if z is undefined. If so, I go about it. So, 1, 2. B value now becomes 3. Very good. We have handled that problem. Just for the sake of interest though, console.log z is undefined. let's throw that in there and see what happens. Add 3, 1, 2, 1, 3, z is undefined. Add 3, 1, 3, 0. Oh, interesting. Z wasn't, 0 isn't testing as undefined today. Oh, well. Well, sometime that would have worked in PHP. I hate these languages. So anyway, so that's one way of doing it. This is inherently problematic because basically it means that you have to write an if case for every possible combination of non-provided arguments, which is a royal pain, right? And increases the bulk of the code. What we use as an alternative is the so-called default parameter. We can give x, y, and z values that they will take in place of undefined if arguments are not provided. The way that we do this is to write a tiny, tiny little assignment statement inside of the function definition line. So, for example, x is equal to 0, y is equal to 0, and z is equal to 0. So this will not set x, y, and z to 0 permanently. These assignments will be overridden if these parameters are provided during function invocation. But if those values are not provided during function invocation, the default values are used instead of undefined. This is good because undefined is not necessarily a good thing to carry through calculations, as we have seen. So, I'm going to, z can no longer ever be undefined, so I'm just going to remove that stuff there. So, if we reload the page, add 3 with no arguments yields 0. With 1 argument yields just that one number. 2, the sum. 3, the sum. Huzzah! Very good. We have introduced a problem, however. If you recall from last time, the plus operation is overloaded for both numeric types and for string types. In the case of string types, of course, the plus sign means concatenation. So, here's a question. What happens if we provide a string? Well. I don't think that we wanted 100 there. So you can see what has happened. The string here has coerced the addition operations, what you formerly were addition operations, into concatenation operations. The default values not provided are set to 0, and if you concatenate numbers into a string, that is what you get. You get 1 concatenated with 0, concatenated with 0. 100. So the problem, the big ol' problem, is that when we set these default parameters, we assumed typing. And it's kind of hard not to when you're writing literals. So, going back to our code here. If this was a string, or excuse me, if this is intended to also be an operation over strings, a default value that would make a lot more sense for concatenation would be the empty string rather than 0. Right? So, I am now going to show you how it might be that in JavaScript you can tell the type of something, since this seems to be a continuous problem with JavaScript. JavaScript has a type of operator. The type of operator returns a string naming the type of the thing that we feed into it. Now, type of, unfortunately, it doesn't quite function like a function. You can see the round braces are left off. This is like a function call in in a different language, in a different paradigm. There are a lot of places where space means application of an argument. One of those is in Bash, and the other is in functional languages. But here, I'd say that this is somewhat out of place in JavaScript, but, what am I, it's JavaScript. So here's an interesting thing. What is the type of 5? The type of 5 is not integer. The type of 5 is number. What about the type of 5.6? The type of 5.6 is also number. JavaScript does not recognize the difference between floats and ints in its type system. They are the same type. So, this is not necessarily a problem, as most of the same operations are defined for integers and for floats. But, certainly when it comes to memory, it makes a difference. So, what we could do, we could say something like, if type of x is number and type of y equals number, you can see where I'm going with this, and type of z is equal to number, I'm just going to full screen this for a moment. There we go. Return x plus y plus z. Else if the type of all of these things is string, if x is equal to 0, well, actually, we could say something like x is equal to 0, or weak equality will work. There you go. Have you folks seen this one before? Put your hands up if you've seen this construction before. Do you know what it's called?
ternary operator?
That's right, it's called the ternary operator. So, ternary is basically just a little tiny inline if statement. It doesn't glue statements together, it glues expressions together. So, if I have an expression like this, condition question mark A colon B, you can actually throw these in anywhere you would throw in a regular, not a regular expression, an expression, a normal expression, not a normalized expression. Oh, so much terminology. So basically, the ternary operator evaluates the condition. If it's true, it grabs A, and then it returns it. If it's false, it grabs B and returns it. By return here, I just mean that is the calculated result of the expression. So this is a compact notation for doing 3 if statements, just, all in one line. So the way that I'm using it here, if x is equal to 0, I output the empty string. That gets assigned back to x. Otherwise, I just take the value of x and assign that back to x. So, in effect, if x is 0, it gets reassigned with the empty string, otherwise we leave it alone. Does that make sense? Hopefully? So we're getting more and more on track to something that resembles how Java would handle a function like this. Add 3. One. Oh, undefined. What do you mean undefined? Oh. Else console.log type error. I'm also going to change these ands to ors. So the bug that I was encountering, in order to execute this block of code, I was requiring that all 3 of x, y, and z were of type string. But if those arguments are not provided, they are substituted with numbers, not strings. So in the case where I was not supplying, when I was undersupplying the function with arguments, I was never going to end up with strings for the not supplied arguments anyways. So I've made this an OR. If any one of the inputs is a string, then the whole thing will be coerced to a string, which is how the operator operates anyways. So, there we go. Let's try again. Add 3. There we go. Adding 1. Potato. And snow. There you go. And you can see it's now behaving as you would expect it to. Except for one thing. If I enter a 0, that also gets converted to a null value, or to an empty string. Because, remember, in our code, we are testing to see if the thing is equal to 0. So, how might we quickly and easily fix this code so that if we enter a string 0, we don't hit these conditions? We can do this quickly and easily. All we have to do is add 3 characters. Any ideas? No? Do you folks remember strong versus weak equality?
So the triple equal?
The triple equals. So the problem that we're having, x is received as a string, the string 0. Here, it tests as the same thing as the number 0 because we're using weak equality here. But that's not what we intend. If it's a string, we want it to just bypass and be processed normally, even if it does happen to be equal to 0. So, if we tighten that up with strong equality, then you see that the 0 is carried through and concatenated the way that we expect it to be. Make sense? Any questions? So the whole problem, the reason that this is so complicated, is that essentially we are having to handle the situation where our input arguments are either numbers or strings. This is somewhat silly because the name of the function itself implies addition and therefore implies the numeric type. What we could also do is we could just say, if type is not number for all 3, output an error message and some kind of error value. But there you have it. That's all I have to say on the topic of trying to make JavaScript behave just a little bit more like Java in terms of having a decent type system. You, yourself, good students, are responsible for any kind of type checking that you want done, because JavaScript is not going to do it for you. Make sense? Any questions? Shall we move along then? People are paying attention, right? Yeah. Can I get a thumbs up? Okay. Good. You guys are very quiet today. So, the next set of things that we have to talk about are ways in which JavaScript derives or pulls influence from another programming paradigm called functional programming. How many people have heard of functional programming before? Has anybody heard of the programming languages Haskell, OCaml, Scala? No?
You
Yeah?
gave a brief introduction of Haskell last week.
Did I now?
Yeah.
Okay.
Everything is a function.
Everything is a function, yes. So, yeah, it's not the purpose of the course to teach you Haskell, but this is kind of, just a quick Google image search is often instructive. So this is what Haskell often looks like. The title of this page is "What Even Is Haskell?" which is a good question. I wrote my thesis work in it, and I'm not quite sure I know what Haskell is. But there we go. This is kind of what Haskell code. It's kind of cut off on one side, but this is what Haskell code looks like. It's basically, the idea is functions are first-class elements of the language, right? So what do I mean by that? In JavaScript, as in Haskell, functions can be arguments to other functions. Functions can be the return results of functions. Now, Haskell takes things a little further than that, even. Haskell, for example, considers like normal integer literals to be functions taking no arguments. This is because this style of thinking derives from an alternative programming paradigm, like an alternative mathematics to the programming that we use in sort of normal imperative object-oriented programming. Does anybody know what the computational model of object-oriented or imperative programming is? Anybody know what that computational model is called? Do you know what I mean by when I say computational model? So a computational model is a set of mathematical rules which describe computation. Our processor architectures follow what is called von Neumann architecture, which basically says we have a memory unit which is external to the processor. Data flows into the processor from the memory unit, gets processed via instructions, and then travels back to the memory unit. This is fundamentally derived from the idea of the Turing machine. Now, how many people have heard of a Turing machine? A few of you. For those of you who have not heard of a Turing machine, there are lots and lots of good, videos on the internet. Go watch them about the Turing machine. It's very, very important and fundamental. Essentially, the idea of a Turing machine is that you have a hypothetically infinite amount of tape. You have a read head that can read symbols off of the tape, write symbols onto the tape, and move around based on what it's read on the tape. That's the idea of a Turing machine. Many early computer models were attempts to directly create the Turing machine in computational form. Like, have you ever, anybody ever watched like old James Bond movies? Sometimes. In those movies, sometimes in the background, they will have old, like from the 70s, magnetic tape computers, right? They'll have like a wall of these cabinets with these great big things that look like the insides of cassette tapes on the walls, right? Great big spools of magnetic tape. Well, that's what those were doing, right? Those are memory units for the computer, and what it's doing, it's got a read head which it can set the state of the magnetic tape to north or south, 1 or 0, right? And it's going forwards and back, forwards, back, forwards, back, forwards. It's a Turing machine, right? Now, the alternative, or one alternative, there are a few different alternatives to the Turing machine. It was eventually proved by Turing and his PhD supervisor, a man by the name of Alonzo Church, that all models of computation are computationally equivalent. That is to say, the set of things that a computer can compute that's based on a Turing machine is the same set as the set of things that a computer can compute that's based on any other computational model. A subset, like a direct consequence of this, is that any program written in any programming language can be written in any other programming language. This is a very, very important property of programming languages called Turing equivalency. So, Alonzo Church is Alan Turing's PhD supervisor, right? He has his own model of computation, which much more directly resembles calculus, like calculus as in functions and calculus and, you know, derivatives and integrals and all of that sort of regular mathematics. He calls this lambda calculus, right? So, although all of the like something like Haskell fundamentally has to be compiled down to a von Neumann architecture anyways, right? You know, fundamentally it has to run on the CPU, right? The advantage of the Turing machine is you could actually implement that in electronics. That's why it blew up, right, as a model of computation. Languages will attempt implementations of essentially lambda calculus, even though the compiler does a bunch of fancy stuff to convert it in the back end. Haskell is a language that uses lambda calculus as its model of computation instead of the Turing machine. That's why writing Haskell feels completely different to writing any other language that you've learned so far. Now, Haskell is mostly an academic language for eggheads such as myself, Poindexters, etc. But what generally happens with programming languages, you have languages on the fringe that do interesting things. People see the interesting things those languages are doing, and where it's useful to do so, they implement language features in the big languages that mimic the behavior of those outside languages. So that is where the concept of a lambda function comes from. Now, how many people have heard of lambda functions? So, lambda functions are something that you will find increasingly. They are increasingly a part of regular, normal, sort of, I almost want to say mainstream programming languages. C++ added them some time ago. Python's had them for some time. JavaScript has had them for some time. You can get them in Java as well, lambda functions. Although, you know, Java, like, a lot of the reason people like lambda functions is that it allows you to write more compact code. Your typical, like, Java implementation of something is not, like, compactness is not necessarily what you're going for in Java. So I think in Java it's like, you know, lambdas are there, sure. I don't know if people, like, use them as much as they do. Certainly not as much as in JavaScript. So basically, over time, it has become the case that lambda functions, were taken up by the JavaScript community, added to the language, and, in contrast to many other programming languages, or at least, you know, the surface level of most other languages, very important standard library functions in JavaScript expect you to know how to be able to use anonymous functions lambda functions and anonymous functions are the same thing, by the way, and function references, right? In JavaScript, this is not optional knowledge. That's why I'm covering it now, you know? I thought I'd give you a little bit of historical background on it. So, the first question that we have, the first sort of concept that I need to throw at you is the concept of the anonymous function. So what does anonymous mean?
Doesn't have a name.
It doesn't have a name. That's right. All of the anon accounts, right, on choose social media platform. So anonymous accounts are accounts with of people who do not share their real names on the internet, right? A little bit different with, like, true anonymity is you just don't have a name at all, right? So in order to get to anonymous accounts, we must understand that the way JavaScript thinks of function declarations is that it thinks of the function name that you give it as a variable of type function. I will give you a demonstration. So let me define a couple of functions in the console for us. The function hello console.log. Ta-da! There we go. If I call hello, ta-da! Function. Now the question then becomes, what happens if I leave these round braces off? You can see the preview is telling me F, somewhat curly-cued F. This means that this is a function pointer. Function pointers, please don't be scared by the term function pointer. I give you leave, you may think of it this way. A function pointer is just a variable containing a function, or pointing to a function, rather than some solid type, right? Think of it this way. What is a function in memory? Like if we were to peel open the RAM and take a look inside, and we looked at a function, what would we see? All right? Give me your most basic definition of a function in a programming language. What is a function?
Block of code that can take in potential arguments and then give you an output.
Yes. So a block of code which takes input and produces output, right? Let's focus in on block of code. What is a block of code?
Variables and operations.
Yes. If we were to put it slightly differently, we might say it is a sequence of instructions, right? All functions are sequences of instructions. The program is held in memory, right? The sequence of instructions which define any program we want to write has to be held in memory somewhere, right? The actual instructions constituting the program, that is held in memory. If it's held in memory, then we can point to it in memory, right? That's what a function pointer does. But it's okay for you to think of it as a variable containing a function. Alright? So, if I ask the JavaScript console to tell me what hello is, it gives me the definition of the function. Now, this was function declaration in the usual manner, in the manner that we have seen so far, and in the manner that is analogous to the way things were done in Python, to the extent that you guys did functions in Python. You guys did functions in Python, right? Okay. I'm being a little facetious. Of course you did functions in Python. So, in JavaScript, an exactly and precisely equal way to declare this is the following. Let hello2 equal function console.log gasp. There you go. This way of declaring the function operates in precisely the same manner as this one. These two are exactly, logically equivalent to each other. So what is the difference? Here, I am using variable declaration syntax. Let hello2 equal, right? That is the way that we define any other variable in JavaScript. Next, I have the part where I declare the function. Function, what's missing? What's missing? Hey?
The name of the function.
The name of the function, that's right. The name of the function is missing here. Otherwise, the function is exactly as you would normally put it. And just to prove to you that these are equivalent, if I run hello2, I get its output, and if I don't run it, I get the definition. These two are exactly the same in JavaScript. Function names are variables containing functions. Make sense? So far, so good? So, all right. This syntax is a little bit clunky. All right? There is a more compact syntax in JavaScript that makes this look more like a lambda in another programming language. And it is the following. You take out the word function. You can, if there's only one statement, you don't need the curly braces. You put a double-ended arrow in there. You can wrap it in parentheses if you wish. But this is inline function declaration. This is a lambda. Lambda. Greek letter. Lambda. That is a terrible marker. Is that one of mine? I think it is one of mine. Oof. Let me try that again. Lambda. Greek letter. So, if I run that, again, everything runs precisely the same way. I've just shown you how to do the same thing in 3 different ways. Does this make sense? So far, so good? So now, I'd like to show you like how lambdas work a little bit. It's a little bit like, it's a little bit different than, how these guys work is a little bit different from how declaring using function, the anonymous function works. Similarly to the difference between an if statement and a ternary operator, the function is like function, anonymous function, function with no name. That's kind of what you will use if you want to put in multiple statements. Or at least that's what you can do like both with either, but this is my recommendation. If you're writing a block of code with multiple statements, go for an anonymous function. If you are writing something smaller and more compact, just an expression, go for a lambda. So let me show you something that you can do with lambdas, right? So if I write lambda 3, I have to execute that in order to get the 3, right? So you should begin to think of round braces as the function application operator or the function execution operator. When you apply arguments to a function, that executes the function, right? So, okay, so I've got a function, takes nothing, and just spits out 3. If I run that, I get 3. Okay. How about a lambda taking x, calculating x plus 3. If we apply no arguments to that, we get not a number. Why? Undersupplied arguments produce undefined. Undefined plus 3 is not a number. If we supply an argument, the calculated result, so if we supply 6, 6 plus 3 is 9. Does this make sense? Hopefully. So if you want to somewhat more formally define what a lambda is, what it actually is, it's an abstraction operator. So lambdas they create functions by looking through the expression, searching it for particular symbols, and setting up replacement rules. Right? So in JavaScript, when I say lambda x plus 3, if you want the mathematical notation for the same, it's lambda x dot x plus 3. That's how you'd say it in like actual lambda calculus. So you can see that's quite, like, this is obviously just a derivation of the lambda calculus syntax thrown into a language that doesn't natively support lambdas, right? So this is what happens, right? The lambda looks through the expression, looking for all instances of x, right? It says, oh, there's one right there. So I am now a function which, when a value is supplied, will substitute x for that value. This is basically the exact same way that functions work in calculus, right? In calculus, if I were to say, f of x is equal to, mx plus b, right? When we calculate like f of 0.37, right? We're calculating m times 0.37 plus b, whatever m constants m and b are, right? This is the same as what's going on with lambda calculus. When I supply an argument here, say 6, this 6 gets substituted everywhere x is in the expression. That gets substituted for 6, we add 3, calculated result is 9. Make sense? Now, it can get a bit more complicated than that. It substitutes every instance of x, right? So here I've got x plus 3. If I substitute 6 into both of those x's, I get 6 plus 6 plus 3, which is 12 plus 3, which is 15. That's our calculated result. Make sense? One that you will see quite a lot is the following. Console.logx, right? Which basically says, it's an inline function that says, whatever I'm passed as an argument, please print me to the console, right? Now, lambdas may also have multiple symbols that they're abstracting, multiple variables that they're abstracting. So, for example, x and y, x times y plus 10. That's a function, taking x and y, multiplying them together and adding 10. If I apply 2 and 3, oh, I think I have an extra brace here somewhere. Yeah, I do. There we go. 2 times 3 is, of course, 6, plus 10 is 16. So you can see that this is a fairly flexible system. Right? Make sense? One thing that you can do, well, okay, wait, before I get into that, a thing that you need to become comfortable with is that this syntax applies arguments to a function, right? If I apply them to a thing that's not a function, it says, problem, 6 is not a function, right? So the round braces apply arguments to functions. Not just function names, anonymous functions too, right? Like up to now, pretty much any time you've applied functions, you'll have done so with an identifier here, a name of a function. But now, we are abstracting away from that. We can apply arguments to anonymous functions as well. Does this make sense? Are you guys following? I know this is kind of heady stuff, but it's important to understand it. So, yeah. Any questions? Okay. So I mentioned that the JavaScript standard library functions, which are very, very important to any use of JavaScript whatsoever, use this concept of anonymous functions and functions being passed as arguments. Let me introduce you to a lovely little function called setInterval. SetInterval is a function which generates a recurring event, right? You specify a time, a period, right, in milliseconds. It calls a function that you pass every time that amount of time has expired, right? So it's like, you know, call this function every 3 seconds. That's what setInterval does. So, if, for example, I call hello every 3,000 milliseconds, every 3 seconds, there you have it. It's calling the function every 3 seconds. Now, there's a pitfall here. If I set interval and I include the round braces here, the problem that we run into almost immediately, what do round braces do? Sorry? Anybody?
They turn it into a function.
Well, they don't turn it into a function. It's already a pointer to a function.
Apply arguments to the function.
They apply arguments to the function and therefore execute it. So, if I provide the round braces here, whenever you have a function call, the arguments must be fully evaluated before they are passed to the function that you're passing them to. So this will be executed first, and the return result of that will be sent to setInterval. So, if I execute the function, the return result will be undefined because it doesn't have a return statement. I will be attempting to set interval of undefined. So basically, every 3 seconds, undefined is called, but undefined is undefined, so it doesn't do anything. And this is JavaScript, so it doesn't even give you a proper warning. But you can see the hello2 function was called immediately upon me pressing enter. Right? Does this make sense? You want a fun example now? I would like to direct your attention to a somewhat popular online game by the name of Cookie Clicker. So, Cookie Clicker kind of epitomizes a genre of video game called the idle game. The idea is that you get cookies by clicking on the big cookie. You purchase upgrades for this cookie on the side here, and then, you know, it makes cookies for you in the background while you're doing your homework, I guess. Right? So, okay, personally, I think that this is fairly pointless, even though, you know, perhaps a large number, I can hear the mice going in the room already. Even if there's like, you know, to some degree, many video games essentially boil down to this, and this is like the you know, 90 proof, 90% alcohol distilled version of many video games that people play. There's some kind of strange thing in the brains of human beings where we like to watch numbers increase, you know? But anyway, so you may notice that this is a website. You may also notice that websites have a console. You may also notice that the developer of this website, hey, how's it hanging? The developer of this website knows that, you know, certain people are going to be looking and snooping around in the console. So let me show you a little trick. And I'm not going to do the obvious one, right? The obvious one is to find the variable for cookies and just give myself 11 billion cookies. I can do that too, but let me show you something that's a little more dramatic. So for this, most of the important game information is held in an object called game. Game has many things, you know, many properties. But perhaps one of the more interesting ones is click cookie, which is a function. Ah, did you see that? I can call the click cookie function, and the cookie gets clicked without me actually clicking it. Now, this is fine, but not fundamentally better than actually just using your mouse. However, we just learned about a function, didn't we? That we can use to call other functions at, repeated intervals. So, set interval game dot click cookie. Notice I'm leaving off the round braces, so I'm passing it as a function reference. Now, how frequently do we want to click this cookie?
Every millisecond?
Once a millisecond? Sounds good. Everybody ready? 3, 2, 1. Now, if you take a look, like there's some kind of there's some kind of effective cap on how fast you can call this function, because that is not 1,000 cookies per second, right? Still pretty good though. What's really impressive, you mouse over there, take a look at all those cookies. Look at all that cheddar. Now, I just want to point out, they are aware, the developers are aware, they practically encourage this behavior. You get an achievement for it. Uncanny clicker, click really, really fast. Well, I'll be. So they know that they know that the game has a JavaScript console. But yeah, and then, you just buy stuff, right? And I think that it's like going so fast that you effectively can't also click, because like you're calling a function that's already been maxed out. But there you go. So there you go. You'll never have to beat cookie clicker by actually clicking cookies ever again in your life. Surprise your friends, astound your enemies.
Is that set interval returning a number?
Yes, it is. That's a very interesting thing. So, JavaScript gives you a mechanism to set one of these up. It also gives you the mechanism to tear one of those down. This is a unique identification number for this event behavior. We can use that number to delete this behavior as well. Clear interval expects a number. If we enter the number that was returned from set interval, you can see that we've gone back down to regular cookie acquisition rates. Right? See the difference? So yeah, so that's what the number is for. The number is so that you can clear it. If if the interval event is something that you might want to clear in the future, what you typically do is you assign the return result of set interval to a variable, because this number is actually like what it actually does is it takes all timeouts and set timeouts and set intervals, and it just numbers them like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see like this running game has already created like nearly 50,000 of them, probably by now 50,000 of them. So like, even though there is a logic to how these numbers are produced, it's effectively random, right? So you want to store the number somewhere. You don't want to like rely on having to look in the console, right? We want to take all of this code and run it from a script eventually, in theory, right? So yeah. All right, now do you want to see me do the thing where I just cheat myself a million gazillion cookies? All right. I'm going to do it. Game.cookies is equal to so many zeros. 1 trillion cookies. I wonder if those are actually
Cheated cookies taste awful.
yeah, hacking some cookies. Well, you know, that's fine. I don't care. I will show you one thing though. All right, if you keep purchasing upgrades, go like, I know. Okay, this is spoilers for Cookie Clicker if anybody cares, but eventually, if you keep going. Fractal engine. One of the actual upgrades in the game itself is the JavaScript console. So they know exactly what they're doing. This game was intended to be broken this way.
And there's more past the draw.
Well, oh yeah, well, you know. If you want to see what's past JavaScript console, then you can cheat yourself as many cookies as you like, and you can go and see it. But basically, actually, it's kind of brilliant because, like, how much free advertising did I just give Cookie Clicker? You know, just because it's like a good in-class example. But yeah.
So how do they make money? Advertising?
I have no idea. There doesn't seem to be any advertisement here.
Or do they like
Merch.
borrow your computing power for like crypto mining?
See, like there was a point where that was like viable, but like even if, let's assume that you could like steal 50% of the processing power on someone's phone to mine crypto. Like you would have to have like every phone on the continent to like produce the equivalent like processing output of like 10 or 20 graphics cards, you know, like, and like, yeah, it's really not worth it to mine crypto on, well, maybe for like smaller like BS currencies, you know all the little ones that keep popping up, you know. Like meme coins and that type of thing. But yeah, so, there you go. Someone's trying to beat my record by hand, eh?
We have infinity cookies.
Wow, just infinity? Wow. Game.cookies equals infinity. Oh, there you go. So that's another thing about JavaScript. There's an actual honest-to-goodness infinity literal. Which, you know, I think you can just, yeah, it should just work, yeah.
Would you have gotten the same result if you took like game.cookies equals 1 divided by 0?
That's a good question.
Yeah.
Yep, that's still infinity. So that's interesting, right? So in most languages, you end up with, if you attempted to do that, you'd end up with a zero division error, right? And it would, in theory, crash the program. So what JavaScript does, and you know, maybe this is like one of those instances where maybe this was a cool idea, JavaScript. Rather than just immediately crash the program, it actually carries an infinity literal through your program. So yeah. So yeah, the point of this brief bit of fun is not that you can just break a cookie clicker and literally assign yourself infinity cookies. The point was you can set a function reference. You can use function references and functions together to produce interesting behavior. Okie dokie? So, I think that it's actually about time for the break. So why don't we come back here at 11:25. I'll give you the extra minute today. Please be back here at 11:25 and we will resume class. Thank you very much.
Can you get negative cookies then?
All right, we're back. So, functions as arguments to functions, right? I know that today has been like a lot of talking and not much in the way of like practical. You guys do some try some exercises. We will get there, but I'd like to press on so that you folks might have a chance to work on assignment 2 over break week. So, speaking of assignment 2, shall we take a look? How did assignment 1 go, by the way? Good. Well, we shall see how assignment 1 went. I had taken a look at a few of the early submissions, and let's just say, of like the 5 that I looked at, I was not really that impressed, because 3 of them, people didn't even manage to get uploaded to CS Unix. 3 out of 5, that's not a good sample, right? And then the other 2, it was like, wow, literally all they did for like the bootstrap part is like wrap the whole page in one container. And it's like, your mark will reflect the amount of effort that you put in. Also there was one that was really hilarious. You know how I said, don't use breaks unless it's poetry? You remember me saying that? I was pretty explicit about that, right? I get this submission, right? It's a paragraph. It has line breaks in it. It's not poetry. The line breaks were mid-sentence. And like, I would condone that. Like, the only thing I can think is that this person was using some kind of like WYSIWYG to HTML software where like enters were being converted to line breaks, right? And like this person didn't like how the text was fitting, so like went to the ends of the lines and pressed enter and like let the thing do its job. Not to mention, I could tell that it had been, it had been put together by a substandard HTML, like WYSIWYG. Do you guys know what WYSIWYG means? Good God.
It's a good thing we don't know what it is, right?
What? You see is what you get. WYSIWYG. This is the design principle. There was a big debate that went on in the 90s about WYSIWYG versus like just normal stuff. Windows took this as like its design philosophy in the 90s. This is why Microsoft Word, for example, the page looks like how it prints, right? Older text editors, better text editors, do not use WYSIWYG principles. Like, for example, the thing I use for all of my document generation is called LaTeX, which is what's used by scientists and Linux aficionados, and that is a non-WYSIWYG. It's like basically it's a bit like programming code, but it produces a document instead of a program. That's the best way I can describe LaTeX. Anyway, what you see is what you get. What was I even talking about?
Line breaks, mid-sentence.
Oh yeah, like WYSIWYG, I could tell it was a WYSIWYG HTML generator because, like, holy hell did it have validation errors. Like, for the amount of text for the amount in the file, the number of validation errors was actually quite impressive. Because it, like, every single line had a problem, you know? Anyway, so, assignment 2 then. The TLDR, you're gonna take Bootstrap JavaScript enabled components, such as we discussed in class. You're gonna stick little JavaScript programming problems inside of them, and that's assignment 2. Alright? So let's go through it. And that should be good. Alright, y'all know what it is. No, we'll go through it in a bit more detail. So, yes. So, in this assignment, you are required to submit one HTML file, one JavaScript file, and at most one CSS file. So a CSS file is actually optional on this one. You are not required to submit one. If you use Bootstrap effectively, you can get away with using a very, very minimal amount of CSS, possibly no CSS at all, if you use Bootstrap well. Alright? You can even do things like adjusting padding and margins with Bootstrap. Logical directory structure, blah, blah, blah. JavaScript must appear in your external JavaScript file and must be loaded in the head element. I do not want to see anybody sneakily loading their JavaScript at the bottom of the file to get around the fact that the DOM isn't loaded until, so that the JavaScript loads after the DOM loads. There's a correct way to do that. We will be discussing it in class. JavaScript gets imported in the head. Thank you very much. You are expected to use creativity to design this web application and talent to implement it. I'm just being silly. There is no standard solution to show you for this one because basically there's a pretty wide disparity in, there's 6 different versions of this guy. So, from the list of components on the Bootstrap 5 website, choose a component other than carousel, which is the one we did in class, to present the output from your solutions to the problems described below. Some suggestions of appropriate options include accordion, collapse, modal, popover, scrolls by, and toasts. So, I know that accordion is the first one in the list. Please don't everybody do accordion. Alright? It gets very boring looking at accordion after accordion after accordion. Look, see? There are 1, 2, 3, 4, 5, 6 options. I'm presuming that most of you should have one hexahedral number randomization cube in your possession somewhere. If not, you can borrow one from a friend who plays Dungeons and Dragons. Even if you don't play Dungeons and Dragons, everybody should have a hexahedral die. That's just the cube, right? Take it, roll the die, and do the one the die said if you don't want to make a decision about which one to do. Okay? Just don't everybody do accordion. Okay? You are permitted, and in fact expected, to copy the code from the Bootstrap website as a starting point. However, you will have to modify that code by putting in your JavaScript problems. Okay? Pay attention to the following paragraph, as there are quite a few actual marks given out for having read and understood this, and for faithful implementation of this paragraph. The content of each section of your chosen component, similar to each slide in Carousel, will be the output to a programming problem that you have solved in JavaScript. Each of these containers should have an input element and a text area. Note that text areas are not the same thing as inputs. The text area must have the attribute read only and be used for your solution output. You should give them ID attributes to make selecting them with JavaScript simpler. Simple patterns like ID Q1 input and ID Q1 output will make it easy to label all of the elements uniquely. Each input element should have an onChange attribute that corresponds to the function you create. See below for naming suggestions. Note, do not put your inputs inside of a form. This way you don't have to cancel form submission. When you put like a text box, like a text input inside of a form, depending on how it's configured, it can like trigger form submission when you hit enter, right? We don't want these to be forms that we are submitting. We just want like input elements from the forms library, I guess you could say. So just don't put them in forms, okay? Okay, good. Any questions about that so far? OnChange attribute. If I see any onClick attributes, I will assume that you didn't read. If I see any buttons, I will assume that you didn't read. This actually does not call for a button that says execute JavaScript, right? So, good. So, the JavaScript problems kind of read like assignment questions. Actually, they read a bit like test questions. So there are 3 groups of problems. The first 2 have 3 problems in them. You are required to do 2 problems from those groups containing 3 questions. The final one has 2 questions. You are required to do 1 of them. Okay? So basically, for each group, the number of problems you actually have to solve is n minus 1, where n is the number of problems given in the assignment. Okay? I'm not going to go through the individual problems themselves. They're very like kind of IPO, you know, calculate the thing type problems. You know, each of these should be well within the within scope for people who have made it this far through the program. Basically, group 1 are kind of easy ones, group 2 are middlingly difficult ones, and group 3 are a bit more challenging. So, it is my expectation that you will solve these problems yourself, and that you will not use the accursed chatbot to solve these problems for you. Alright? I know that these are easy problems that the chatbot can easily produce an implementation for you. Alright? That's not the point. The point is that you are trying to learn how to program. And if you over-rely on the chatbot or similar things, you are going to miss out on essential skills that will affect your future work performance. Alright? None of these questions is sufficiently hard that you should require the chatbot. Secondly, I don't want to see use of regular expressions here. Does anybody already know what regular expressions are? A little bit? Well, basically, at this point, you are not really equipped to understand what you're doing when you're using regular expressions. You haven't been taught regular expressions. If you have pre-existing knowledge coming into the program about regular expressions, that's a different thing. But basically, if I see regular expressions, I'm going to think to myself, this person got this solution from somewhere. Right? The reason I say this is that the solution that the accursed chatbot is going to come up with for at least one or two of these will most probably use regular expressions. Right? So if I see regular expressions, I shall be severely ticked off. Okay? Because it's beyond you at this point.
That's the regex stuff, right?
That's regex stuff, yeah. Now, regular expressions are extremely interesting and useful. If you want to experiment with them, there's a great website called regex 101. What a regular expression is it's basically a way of searching text. So if I have some text, like this, paste it in. If I search, if I write a regular expression like, let's say, value, the regular expression pulls up every point in the text that matches this, this thing. But the interesting thing about them is that you can do things like, maybe I want to match the word value or the word in. Right? Oh, I meant the word in, not use of I adjacent to n everywhere, so maybe I throw in, so to speak, spaces, and now I'm just getting the word in. Right? So this is kind of the flavor of regular expressions. It uses a model of computation called a finite state automata. It is well beyond anything I would expect a second semester student to be able to do unless they were quite highly advanced in their programming journey, or a Linux user, like a long-time Linux user needs to know this kind of stuff too. So yeah, just they're not for you, not yet. You'll get there, but just, if I see solutions that use these, I'm gonna be picking through very carefully to see if I can find any other evidence of plagiarism. Okay? And tell your friends that didn't come to class, because they're usually most of the problem. I know when I say this kind of stuff, I'm preaching to the choir, but so it goes. So, miscellaneous requirements. You must use Bootstrap 5. All right? Any other version results in a grade of 0. A little bit harsh, but just use Bootstrap 5. I don't want to have the hassle. Use semantic elements wherever possible. Follow the suggestions in the HTML style guide and validate your code using the HTML validator. that one particularly. If you take a look at the actual honest-to-goodness rubric, it is impossible to achieve a passing grade in the HTML/CSS category on the rubric if your HTML does not validate with 0 errors. Warnings are different, but you should have exactly 0 errors. Okay? Make sense? Everybody's gonna run it through the validator? Good. You know, you can, like...
So what kind of warning should we avoid? Because there's like a whole bunch of them.
Well, in general, you should avoid all warnings, actually, but, like, I don't know, give me some examples.
Because I think sometimes they'll give me the warning if I add the ending slash for some of the...
Oh, yeah, that's... That's a minor stylistic point. Would it be best if you followed what it said? Yes, but is anybody gonna like? That's not a sufficiently important thing, I think. Any other? Yeah. Okay. Good. So. Let's move now to document object model manipulation. So, in order to demonstrate this part, I have to put actually some actual honest-to-goodness content in this thing. So, let's make a heading. This is a heading. Oh, I guess in honor of St. Valentine's Day, L is for the way you look at me. O is for the only one I see.
Bringing out the big cross, yeah.
Yeah. V is very, very extraordinary. E is even more than anyone that you adore. Which is a little bit creepy.
So some lyrics count as poetry.
Yeah, well, yes, absolutely. Song lyrics count as poetry. That's what music with lyrics is it's just it's poetry that's been set to music. With a few rare exceptions that we don't want to talk about. So there you go. Today is St. Valentine's Day. Let's just throw a div down here and div. Ooh, I'm gonna put a form in. Form, end form, input. Ooh, yeah. Send H4. Send a message to your Valentine. If I had had the foresight, I would have brought like conversation hearts or something for you guys. Input type is text. Message. Input type equals text. Value equals name of your Valentine. And input type equals submit. Value equals send message. Heart. There you go. A website. Okay. So far, most of the work that we've been doing, learning JavaScript semantics, has been in the JavaScript console. Remember that the console's full title is the JavaScript Developer Console. These are not changes that will be seen to the by an end user, because 99.999% of end users don't even know what JavaScript is, let alone the console, let alone being able to open it. Right? If they get there, it'll be completely by accident. So, when you make modifications to a page using JavaScript, we need to know how to navigate the document object model. So recall that everything inside of the HTML document is organized hierarchically, right? We got things inside of things inside of things, right? The document has parent elements with child elements. A couple of relationships inside of this very document. These input elements are they're children of the form. The form is a child of this div. The div is a child of body. Body is the child of HTML. And HTML is the child of document. That's the thing. And document is something you always have a reference to. Document is always called document. So, for example, if I ask for document, well, when you print it, it says, okay, here's your document. But document has lots and lots and lots of properties. One of the properties of document is children. This actually returns a collection type of all of the so what children returns is a list of all child elements, right? You then have to index it to get which one you want. So if I say children at 0, that's the HTML. If I say .children at 1, that's the body. If I say .children, I've got h2, p, and div. If I say at 2, that's the div. Children at 1, that's the form. Children at 4, 3, there we go. That's the submit button. So, what we can do is we can use children to step our way down the hierarchy, right? Document, HTML, head, body. This will have a script, etc. Right? Using children, we step down the hierarchy. But this is, well, you can kind of tell just by looking at it, but this is a bloody terrible way of doing this, although it is possible, right? Can anybody use your brains, use your fancy meat computers? What do you think a problem with this would be, doing it this way? Long code, yep, certainly not compact.
Hard to tell with the index numbers, like you could pick the wrong one and then you're kind of screwed.
Yeah, it's like it's not obvious what children one in this context actually means, right? Can anybody think of another problem with doing it this way? There's a big one that I'm thinking of. Can anybody guess what I'm thinking? If the HTML file changes, that breaks. Right? If we add any children to any element, this breaks. If we take anything out, that breaks. So basically this has assumed like a hard-coded version of the HTML file. Since development will most often go in parallel between client and server and HTML, CSS, and JavaScript, these are different people working on the project at the same time, right? This is not really an acceptable way of doing things, even though it demonstrates what the DOM looks like, right? Instead, we use search functions, right? We use methods to search the DOM for things we're looking for, rather than directly addressing them, right? So, there is a collection. There's kind of an older collection and a new one that I would prefer you use. Document dot. So the old way of going about this is get element. Element. There we go. So get element produces a series of methods, each of which targets things in a slightly different way. We have one which targets things by ID, by name, by tag name, by class name, and by tag name and S. So each one of, although between the collection of them they'll target anything in the page in any way you want, it's a little bit, it's not really as flexible as the new way of going about things. The new way of going about things, which is actually, it's been borrowed from jQuery and sort of pulled back into the sort of native JavaScript or vanilla JavaScript, is to use CSS selectors, right? CSS selectors already do this job, and they do it well. Better than those things do, right? So, that being said, if you look at websites, you will see this guy quite a lot, right? Established practice in JavaScript for quite some time has been to use get element by ID, use something in this suite of methods. These will probably eventually be deprecated. They're not quite deprecated yet, but one could see these being deprecated in the future. You're kind of always obligated to support them once they exist in the language once. But you'll see this a lot, so you should know what it does. All it does is it grabs an element, a reference to an element of the DOM given its ID string, but it'll never quite go away, but like practice is moving away from this way of doing things. The way that we want to do it these days is using query selector. We've got two variants of query selector. We have query selector and query selector all. So a thing that you probably should understand about CSS queries is that they can select multiple elements of a page at once, right? A CSS rule for a div applies to every div in the document, right? The difference between query selector and query selector all, this one will yield a reference to to the first element matching the query, this one will yield a list of all elements matching the query. Make sense? Any questions? So, for example, if I were to select, or if I were to ask for paragraph elements, there's only one on the page. There you go. And perhaps I want to set one of the properties up now. So there are a few very important properties. Inner HTML is an important one. That is the actual contents of the tag. I can assign to that at will. Hello, world. It replaces the inner text of the HTML, the inner text of the tag, or it replaces all of the characters between the closing of the opening tag and the opening of the closing tag with whatever you've assigned. Does that make sense? You can also introduce additional DOM elements this way. Strong. Hello world. And now it's strong, right? So you can throw in additional HTML elements this way. This is not necessarily the way that we endorse doing things. As we go through the course, we'll see that there are different, better ways of doing this. But this works. This is like your basic version. We're going to do a better version of later. Okay? All attributes of HTML elements can be accessed using this method. So, for example, if I query select input, and inputs don't have inner HTML, but they do have values. Right? So the value is, of course, the text inside the box. We can modify that using .value. Your HTML attributes will have the same names, broadly speaking, in JavaScript as they do in HTML. Any questions about this so far? It should seem fairly straightforward. Let's now talk about CSS properties. Right? So a CSS property, if you were to assign it in line, what attribute would you assign it to?
Style.
Style is correct. So we have the style attribute using DOM access. You can see that we have a big old list of basically every CSS property that exists. Boop. And there are quite a few. You have to be a little bit careful. You can't say something like style.background-color, which is the way you would access it regularly. Reference color is not defined. What does that mean, color is not defined? What's happened here? Any guesses?
You're trying to access something that doesn't exist.
I'm trying to access something that doesn't exist. Yes, it's saying that color doesn't exist. So what does that say about this guy? The hyphen. it's a break in the word, yes, but it's doing more than that. So in CSS, that's just how you would refer to this, right? But here, that's not working. And does anybody care to, yes?
Is it like subtracting or something?
That's right. It's interpreting the hyphen as subtraction. That's a mathematical operator in JavaScript. So, how does JavaScript deal with this problem? It takes things that are hyphenated CSS properties and just converts them to camel case. Right? You guys are familiar with the different types of cases? Do you guys know what I mean when I say camel case?
Starts with lower capital. First word is lower capitals, and then the rest are all capitalized. And then
Yes, with
half
no
stop.
spaces. Yeah. So this is here. This is camel case. Well, actually, that kind of looks like it has spaces. So here, let me try that again.
They introduced us to 3 cases for Java.
Okay, good.
Then Pascal is the first one is capitalized, and then there was another snake case would be underscore.
Yes. This is snake case. I like to be a bit of a rebel, and when I'm in Python, not using snake case but using camel case. And what was the third one?
Pascal.
Pascal.
So the first, it's like camel case except the first word is capitalized.
So this one generally is reserved for classes, right? This is a convention that is pretty much universal across object-oriented languages. If you have a class name, even if you're allowed to make it lowercase according to the language semantics, you always make class names uppercase, because that way you can tell a class name from an object name, right? Objects always lowercase, classes always uppercase, okay? So, good. So that's how you can modify CSS properties from within JavaScript. Any questions about that? All right. So, how might you go about pulling information from your page into, I don't know, a JavaScript function? At this point, we should head over to script plan for a moment. So, function blanking. Repeat. So, with this function repeat, my object is to take the value of one of these inputs and then to repeat that message twice somewhere else on the page. right? So, the first thing you should always do when you are writing a function that is doing DOM manipulation is you should always get your references first. This is part of the I in IPO, right? So, document dot query selector input. That grabs a reference to the input value, or to the input element. And the next thing I want to do is I want to assign that to a variable. Let input equal document.querySelector input. Now, I'm not really expecting anybody here in your second semester of this program to be able to write terribly efficient code. That's not my expectation. You guys don't really have a good concept of efficiency until you've done data structures and algorithms anyways, right? So, right now, your focus should be learning how to write programs that are correct rather than programs that are fast, right? That's more than enough to chew on for the time being. That being said, I'm going to talk a little bit about efficiency. So, basically you've got two options for how to perform, how to grab these references, right? You either grab them once at the top, cache that information, and then use that throughout, or you use query selector every time you need to access the element, right? So if you use query selector every time you have to access the element, a thing that you should always keep in mind about functions, you know, in your program, it looks like one line of code. The definition of this thing has all of its own runtime complexity that it's adding as well, right? So this thing could take a while to run, or it could take almost no time to run. It's a search function, right? All search functions, except for hash tables, take an amount of time proportional to the size of the thing they're searching. So the larger your web page is, the more time it takes to search, right? So the best thing to do in terms of runtime efficiency is to perform the search once and then save that to a variable, use that variable throughout, and that way you're not repeating an expensive search, repeating a possibly expensive search operation. Make sense? Good. We should also grab a reference to the output element. Let output equal document dot query selector. Oh, I think I've got an H4 kicking around there, right? Yeah, this guy. Now, I'm using CSS selectors. I'm just targeting the HTML elements. If you want to do one that's targeting an ID, what do? What character do you use to start? Right? The octothorpe. If it's an ID, you use the octothorpe character to say this is an ID. What if it's a class? Period. Very good. So we have references to our input and output elements. My suggestion for you folks during your development, stop at this point and check to make sure your references work. In order to do that, we'll have to hook up this function to a DOM element. So let's say we want this to execute when we click the button, the submit button. I'm going to take all of this out of the form because otherwise the submit button will trigger form submission, which we don't want. There we go. So, to this, we can add onClick, and then we specify the name of a JavaScript function, repeat. There we go. Make sense? Then, in the function, I'm just going to say console.log input, console.log output. There we go. Very important, before you do any further programming, make sure you've got the function hooked up properly. Make sure that you're reading the elements out of the page correctly. Alright? So, send message. There are our elements. Everything works. Good. So far, so good. Like, because JavaScript doesn't give you a whole lot of errors or warnings, it's very highly important that you take this incremental approach to programming. You should stop every couple of lines of code, try it out, run the thing, see that make sure that it's doing what you expect it to. Okay? Inch by inch. Right? The problem with fixing bugs is the number of lines of code that the bug might exist in. Right? If you test as you go, you can say, no, though everything past this point, I ran that test, that all works. The bug must be in the last 3 lines that I wrote. And that's a much, much easier situation to be in, to say, oh, I don't know where the bug is, it might be anywhere in these 50 lines of code because I haven't tested the code in 2 hours. Right? Test early, test often. So, now that we have established that input and output are correct and that the function executes when we think it does, we now may perform the processing step. So this is gather inputs, process, and then later we will output. In this case, I just want to say the string twice. Something simple, right? Let string equal input dot value, concatenate input dot value, and if we're being nice, maybe we'll even throw a space in there. Next, output dot inner HTML is equal to, set that equal to the calculated value of string. Looking good? Any questions? Okay. Now, if I say emine Valentine. Send message. It does precisely that. It repeats the string twice and replaces the inner text of that H4 element with the string that's being repeated twice. Are there any questions? Okay. Let me see if I didn't forget anything in the notes. Oh, I forgot set timeout, actually. Okay. Backtracking just a little bit. Wait, did I do set? No, I didn't do set timeout. So, set timeout is a similar function to set interval. It doesn't set repeating behavior. It sets a one-time event to be executed in the future. So, for example, set timeout, anonymous function console.log hello from the past. Set that to 2000 milliseconds. Hello from the past executes in 2 seconds. It's a one-time deal, as opposed to set interval, which executes repeatedly. Make sense? So everybody knows what set timeout does now? Okay. Let's see what else.
Yes, sorry.
Oh, yeah,
Can
question.
you show again the code that you used for the website?
Oh, for this one?
Yes, thank you.
There you go.
So assuming you want something besides the first element, would you then have to rely on the IDs and stuff? Or would you like do the select all and then figure out, like, put it into a variable and then select the index out?
That's a very good question. So the question is, what if you didn't want the first element here, right? What if you wanted some other element? In theory, it would be possible to use query selector all and then select the index of the item that you were looking for. Theoretically possible, suffers from the same problem that we had when we said dot children at 1, dot children at 2, dot children at 0, right? If the page changes, everything breaks. So, if you want an element that's not first, I recommend setting an ID. Set an ID and then look for that ID specifically. No matter how the page changes, that will still work. Make sense?
And then we would still use the query selector, just put the number sign of it.
Yeah, you wanna see me do it?
Sure.
I can do it very quickly. Let's change it to the second one. Right? Input ID is equal to merv. There you go. That's it. Executing it. It's now pulling from this one instead of that one. Make sense? Any other questions? Those are some good questions. Okay. So I'll do a demo now of working with multiple object references at once. I'll do one of my absolute favorite things to do in class, which is vandalize Wikipedia. Today's featured article is My Little Love, a song by English singer Adele, pictured. Alright, sure. There we go. Doop. So, let's grab references to all paragraph elements in this article all at once. Document dot query selector for all paragraph elements. Let's assign that to paras. Although I suppose that's also the name of a Pokemon. That's okay. So, we can access individual paragraphs here. Like, for example, paragraph 3 contains something somewhere. It's a little, oh, there it is. Interesting. Paragraph 3 is this one. Presumably, paragraph 2 is the one above. Yep, but it doesn't really matter. So, there are two ways of going about this. One is the recommended way if you didn't really get lambdas when I explained them, and that's to use just a regular, plain, old-fashioned for loop. For let I equal 0, I is less than paras.length, I plus plus. Oh, come on, give me, there we go. Paras at I, oh, come on. There we go, dot, inner HTML is equal to love, song, etc. There you go. And now every paragraph says love, song, etc. Of course, I'm not actually vandalizing Wikipedia. I'm just vandalizing my own local copy of it. This doesn't get pushed out to Wikipedia's server or anything. That would be silly. Does that make sense? So now, I will show you the slightly fancier way of doing this that requires lambdas. And that is using the for each method. Paras dot for each expects a function taking one argument. The function, the argument that this function receives will be every element in the data structure in sequence. The value returning from the function will be assigned back in, or although it won't matter in this case, because these are function references, we don't actually want to modify them. So, for each paragraph, p.inner HTML is equal to lambda functions rule. And there you can see we accomplish the same task in a more compact fashion with fewer curly braces. Lambda functions are very powerful. And as with all very powerful things, use with caution. You know? Like, I've just handed you the big kitchen knife. Don't cut your fingers off, okay? Well, I'll rephrase it. You are, in this case, permitted to cut your fingers off. If you do cut your fingers off, email me your fingers and I will reattach them for you. Okay? That is to say, if you're having trouble with lambdas, please shoot me an email, including your code, your actual code snippet, and I will tell you what you're doing wrong. Okay? Yeah. Because, you know, I'm being paid to teach you. I'm being paid to instruct you. So. Also, like, so far I really haven't been getting that much email this semester. So, you know. Not that I'm complaining, but, you know. Everybody seems to be doing okay, so. I mean, you do get the usual flurry of, I can't upload things to CS Unix, but, you know. It's like, the deadline was when, and you're trying to upload your work to CS Unix today? Gambling pretty heavily on me not doing the marking until reading week, hey? Although that turns out to not be a bad gamble. Well, I mean, like, looking at it objectively, like, I really shouldn't, I took an early look at it, but, like, I shouldn't start seriously marking until after, like, the third day after the deadline, because you can still have submissions come in, right? And then there was a snow day, and, like, today I've got, you know, I've got 5 hours of stuff and not much time to, like, do other stuff, so, yeah, I haven't marked the assignments yet. Don't worry, I will. Expect them by the end of reading week. But yeah, so does that make sense? When you use query selector all, it comes as a list, so you must deal with it as a list. Right? But it also means that basically, query selector is actually like defined as query selector all at 0. Like that's the definition, right? Good. Any questions?
For the lambda functions, can we also pass in like other functions? So like P inner HTML gets like some other function that you've already defined elsewhere. Would that still work? Or is that like, or would you have
Like
to
in
do like
this
a full
particular
function?
case?
Yeah. Or do you need like actual full function to like do that sort of stuff?
This is how you do it. Let's write.
Like we had the add 3 function from earlier. Like, would you be able to pass in that sort of?
Yes. So the add 3 function. So what you have to do is you have to start nesting lambdas to do that.
Okay. Yeah, nesting.
So the problem. Okay. All right. Like. No, this is good. This is good because this is like figuring out lambdas, right? So we have a function. Ah, you stupid. It would have been hilarious.
The budget cuts are making them more.
Yeah. So So what this guy expects is a function taking one argument, right? So we have a function taking one argument. So let's just say it's, you know, p dot inner HTML is equal to something, right? Let's say we wanted to make that the output of a function, right? If you wanted to put that here, right, like that, put this here, call it, let's assume that that function takes no arguments for the time being, right? That's okay, but now this thing is not going to be happy here, right? So, because this now takes two arguments, and this is expecting one, so it's only going to be providing one, so f will be undefined in that case. So you might say to yourself, okay, that's fine. I'll apply one argument, right? To which one? X or f, right? So what you end up having to do is write another lambda, right? Which applies y to x. And then you like provide the function definition here, right? So this results in a function that still accepts one argument, right? That one argument is applied as an input here. This gets applied there. So f becomes hello, x, or actually that should be p, pardon me. P becomes this guy, right? So that works. This still takes one argument. It'll happily satisfy that thing over there. This is kind of like going out and then coming back in again, right? The easier way of doing that is to just leave it p on its own, right? And then inside here, nest a lambda. Lambda f p dot inner, you know, equals f, call it. That's a lambda. Apply the function you want to apply here. And then that's the other way. I think that's slightly easier, but in neither event is it like lambdas can get pretty complicated pretty quickly. For the benefit of those of you who are watching online, and I did that all off screen, there you go. So just pause the video and read that. There you go. So yes, does that make sense? Sort of?
Yeah.
It's gross. That's gross.
So if you're basically just doing an actual full curly brace function, if you're gonna have to do a lot of lambda nesting, basically.
Yeah, well, it's kind of like, I'm not sure that this is actually even, we're to the point where we replace this with multiple statements, even. But like, I don't know what the advantage would be over simply saying p gets p dot inner, etc. is equal to hello, right? That seems like that is, I'm not sure that either of these have an advantage over this in this situation. Just directly provide the function reference. In theory, like, you could abstract that, like, but you know, like part of the problem is that like this is bloody JavaScript, and JavaScript doesn't do currying. So, we're out of time, but basically what currying is like if I have a lambda function with two other functions, say x plus y, right? If I apply only one argument, 3, that substitutes down to lambda y dot 3 plus y. So if you apply one argument, you still get a function out of it, but one that has one fewer argument, right? So that's currying. JavaScript doesn't do that because it does the stupid thing where any unsupplied arguments are replaced with the undefined literal. So you have to do stupid stuff like that in order to get the same effect, right? So lambdas are better implemented elsewhere, but they're still very, very used in JavaScript, and you need to know how they work. So if you have any questions, send me an email. Have a good break week. Goodbye.
When is assignment 2 due? Like,